Hello, we're going to talk in these notes about unit conversions, which is what dimensional analysis means. We're going to start with units themselves, and the units that we use in science, and they're actually the most commonly used units, are what we call SI units, which stands for an international system of units. So that's what this is here, SI units, International System of Units. And this was agreed upon by scientists to use these units in around the 1960s. There are 7 base units. The base units here are, units that are defined by what it actually means, a meter, how long a meter is. So for length, they use the meter, and the symbol is M. For mass, they actually use a kilogram. So people who report data in scientific papers typically report them in kilograms. The unit for time is seconds. The unit for current is amps, amperes, amps, right? And they use a capital A as a symbol for amps. For temperature, it's Kelvin. And for the amount of particles, it's the mole, which we haven't learned about yet, but you will. And then there's one more, and that's candelas, which is for luminosity, the amount of light. So those are base units, and we do conversions with, right, it's basically, oops, I wrote on it. We do conversions, right, with metrics, so it's essentially the metric system. We can convert from grams to kilograms, meters to millimeters, for example. Derived units here are units that are derived from the base units, usually multiplying or dividing. So for example, some examples of derived units, I'm going to zoom in so I can, maybe I'm not going to zoom in. I'm going to go to here, and then I can zoom in. Whoa, too much. Okay, here's derived units. This is just so that I can actually write legibly. Density is mass divided by volume, right? And so that's derived. The density is a derived metric. Even volume itself is a derived unit because we start with base units, length times the width times the height, right? So volume is also a derived unit. Let's see. So, and then we have some examples over here. There we go. I don't really like this. Hold on, I'm going to try to switch colors here. Make it bigger too. Sorry about this. Use purple. Okay. So for example, what are the units for velocity, distance traveled per time? Oops. So we have a distance divided by time. The SI unit for distance is meters, right? So meters divided by seconds, meters per second. Second example, energy is measured in a joule. Joules is kinetic energy, and the formula for kinetic energy is 1/2 the mass times the velocity squared. So let's see, let's talk about what are the units. So the mass, the unit for mass, right, is kilograms. And the unit for velocity, which we just did above meters per second, right? And this is actually squared here, right, per this. So the velocity is squared, which means we're squaring the distance okay, and we're squaring the time. So the unit for joules, the units for joules, for the energy unit is kilograms meters squared per second squared. So if you think about what that means, it's the energy that's required to push a 1 kilogram mass 1 meter per second for every second that it's pushed. And it can go in either direction, the x or the y direction, which is why it's meters squared. It's an area. Anyway, so that's what that means. And then we have specific heat, which is the energy, joules, divided by, so the amount of energy per gram per degree Celsius. Specific heat is the amount of heat that's absorbed by a substance. That's called its specific heat. How much heat can it hold within itself, right? So we're going to have to break down energy, right? So we have energy is joules, and mass is kilograms, and temperature is Kelvin. And we can break down that even further, right? So we have, so because joules is kilogram meter squared per second squared, so we have second squared, kilograms, and we have Kelvin, right? So specific heat, that's the unit, those are the units for specific heat. So a lot of different base units. We're going to be using units a lot. That's the point, okay? When we have metric units, as you see in the bottom here, metric units, these are the prefixes. So metric uses a system of prefixes in 10 increments. Mostly tens. Once you get to milli, it stops going by 10. So notice, after milli, it goes up by 1,000. It goes down by 1,000. So you go from 10 to the negative third here to the next prefix is 10 to the negative 6, and then 10 to the negative 9, and then 10 to the negative 12. Also, when you go up, once you get past a kilo, you start going up by thousands. So a kilo is 1,000 is equal 1,000 units, and then you go to mega. You guys can, I think of these in terms of megabytes, and then after megabytes is gigabytes, right? So kilo, mega, giga, and then there are also terabytes. So those prefixes come from metric units. So each unit, each prefix, remember they're prefixes. You have a base unit, the base unit, which is 0. Well, not 0, it's 1. It's considered 1. It's the ones place. So I like to think of this as the ones place. It doesn't have a prefix. It has no prefix. Prefix. And so these are your base units, right? Not kilograms. This could be grams, it could be meters, it could be, what else do we use? Liters for volume. So there's mass, length, volume. Anyway, that's most of the ones that we use. So notice that this is just the unit, no prefix. Okay, and then if there's a prefix, it's gonna relate that to how many tens. Let's see, as you go down, the unit becomes smaller. So a millimeter, if you look at the ruler, is smaller than a centimeter, which means there are more millimeters. So as you go down this way, right, there are more units, and each unit is smaller by a matter of 10, right? And so the key, this is something to remember when you're converting metric units, is that as you go down, there are always more. So for example, milli is next to centi, and there are 10 milliliters in a centiliter, right? because there's always more millis than centis. Let's go over to the ladder method for metric conversions now. And I'm going to, again, try to scroll in here so I can write at a decent size. The ladder method uses a mnemonic letters for the scale of the metric system. And it looks like this. I'm going to leave some space over here on both sides. KHDODCM. Okay. And this stands for kilo, hecto, deca, and then the ones place. That's the base unit, and then deci, centi, milli. All right. The mnemonic that I use to remember this is, I'm going to put it in blue up here. And you can use, there's several of them. I like this one. Kids have dropped, oops, I forgot the R, dropped over dead, converting metrics. Kids have dropped over dead, converting metrics. Hold on, let me see if I can scoot over here. Metrics. Okay. There's one that kings have died over drinking chocolate milk. I don't know. I don't care what you use to remember KHDODCM. I don't even care if it's school appropriate. I don't want to hear it if it's not, but you're welcome to use whatever it is that helps you remember KHDODCM. And that's the order. Once we get, remember, to the ends here, then we have to put spaces, because now we're going up by 1,000. And the next one is, this is a Greek symbol mu. It's like a U, only it has two curvies, and that stands for micro. What you might see sometimes is MC for micro. Okay. Micro is 1,000 times smaller than a milli. Then we go over another 3. We write N, and N is for nano, which you see is on your table over there. You know, like nanotechnology, right? That's how small nanotechnology is. And then we go over another 1,000, and we have P for pico. As we go up, we do the same thing. Once we get to kilo, we go up by 1,000, and then we have, from kilo, we have mega, and then another 1,000 is giga, and then after that, even, we can put a little arrow here, 1, 2, and now we have tera. Okay, so giga and tera, and we think of those in terms of computer RAM, gigabytes, and terabytes. There are 2 ways to use the ladder method to do metric conversion. So this is kind of a shortcut. And the reason that we do this is because it's not something I'm going to give you. And I'm not going to give you a little table that says that there are 1,000 milliliters in 1 liter. It's something you need to memorize, which is why we have this technique to memorize it. And the trick here is that every unit that you go over here is 10 more. So here, write 1, 2, 10, 100, 1,000 more. So if you look at this, if I give you, let's say, kilograms, all right, if I say 25 kilograms equals how many milligrams, okay? Here's where I'm starting at kilograms, and I can move over, and every one that I move over is 10 more. Okay, so 25 kilograms, and I'm going to add, since there's going to be more of them, right? More as I go to the right. More as I go to the right because they're smaller. So I'm going to move over. This is 10, 100, so 1, 2, 3, 4, 5, 6 decimal places, right? So 1, 10, 100,000, 10,000, 100,000, 1 million. There are 1 million milligrams in 1 kilogram. 1 kilogram equals 1 million milligrams. So 25 kilograms is going to be 25 million milligrams. Or 2.5 times e to the 1, 2, 3, 4, 5, 6, 7, e to the 7 milligrams. Another way that you can use it if you're just doing metric conversions, sometimes you need to know this idea here, that 1 kilogram is 1 million milligrams, or that 1,000 milliliters equals 1 liter, and because you want to use it as a conversion factor like you did in your unit conversions tutorial yesterday, as like that, so to convert from milliliters to liters. If you're just doing metric conversions, there's even more of a cheater method, and that is to just move the decimal point, which is what I did here. So here I have 42.5 milliliters, and it asks me how many liters. And if I come over here and I'm at milliliters and I'm going to liters, which is the base unit, notice there's no prefix in front of liters, so I'm going 1, 2, 3 decimal places to the left. So I just move it 1, 2, 3 places to the left, and I'm moving to the left because I moved from milli towards liters, which is to the left on my my letters, right? So that's 0.0425 liters. Okay. I can do the same thing. Here I have nanometers, which is way over here. And I want to go to meters, which again, there's no prefix in front of meters. This is not milli. If it was millimeters, there would be 2 M's, but it's just 1 M stands for meters, and there's no prefix. So I'm going to move 1, 2, 3, 4, 5, 6, 7, 8, 9 places again to the left, because meters is to the left of nanometers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I'm going to add 1, 2, 3, 4, 5, 6, 7, 8 zeros. Is that right? No. 1, 2, 3, wait. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's actually only 9. So, and then I moved 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's 1, 2, 3, 4, 5, 6 zeros. 3, 4, 5, 6, 3, 2, 5 meters. Okay. I'm going to erase a few things up here so I have a little more so you can see better. I'm going to do this again. This question, it's asking me to go from kilograms to milligrams, and so I'm starting at, I'm going to use blue, start at kilograms, and I'm going to go 1, 2, 3, 4, 5, 6 over to milligrams. So I'm going to move my decimal point 1, 2, 3, 4, 5, 6 to the right, because milli is to the right of kilo. And that means I'm going to add 1, 2, 3, 4 zeros. 1, 2, 5, 0, 0, 0, 0. Right? So 1,250,000 milligrams. Okay. Another thing, so that's how those work if you're just doing metric conversions and you forget how many kilograms are in a milligram. You can use the KHDODCM. Kids have dropped over dead converting metrics to convert metric units. Liters, we said, is a unit, a derived unit for volume, because it comes from centimeters times centimeters times centimeters, and they created this unit, liters, as an alternative to cubic centimeters or cubic meters, and they use this conversion right here. So every milliliter is 1 cubic centimeter. So that's an important thing to remember also. 1 milliliter is 1 cubic centimeter. Okay, so that's metric conversions. And units. We'll do some practice with metric conversions tomorrow in class, and then maybe we'll also watch the next half of the video from the back page, but I'll stop here because we're at 20 minutes.